Hi, and welcome back to Video Talks for Mr. Rocher's biology class. Today we're going to talk a little bit about the scientific method. So this is a method that scientists use to support or disprove a hypothesis. So scientists develop their knowledge by observation and experimentation. This might be something you've done yourself. Say you have a flashlight and the flashlight breaks. If you want to figure out how to fix a flashlight, you can take it apart and try to figure out what's wrong with it. You can take out the batteries and try new batteries. And if that doesn't work, you can always try to take out the light bulb and replace it. So what you're doing is basically making an observation, my flashlight's broken, and you're experimenting to see which of those pieces is actually going to restore your flashlight. Observation can lead to two ways to approach experiments. So you can use inductive reasoning, which goes from specific information or specific cases to very general principles. So for instance, if I drop something on the ground, or if I drop something from my hand, it's going to fall to the ground. If I go to the top of a building and I drop something like a penny, it's going to fall to the ground. If I go up in a hot air balloon and I drop something, it's going to fall to the ground. So I'm basically looking at these specific cases, and I'm going to make a general I'm going to find out there's a general principle behind that, and of course that is the law of gravity. Anywhere on Earth I drop something, it's going to fall to the ground because of gravity. You can also use deductive reasoning. So this is looking at a general principle and following it down to a specific conclusion. So for instance, that might be, I just read a book on parasites, and parasites can change their host's behavior. So a scientist can kind of look at some parasites in general, and then they can kind of work their way down to one organism and say, we're going to look and see if parasites can change behavior in zebrafish. So those are two ways that you can look at things using the scientific method. So the scientific method, most people think it's like a series of steps, like do step 1, step 2, step 3, but the scientific method's really more like a cycle, where you have a hypothesis. You can use deductive reasoning to get to a reasonable prediction. Say zebrafish that have blood flukes are going to be less likely to mate successfully. And then you're going to test your prediction. So you might breed a bunch of zebrafish in a lab and cut open a few and see how many parasites they have and see how many babies they've fathered. Then you can use inductive reasoning to come up with another hypothesis. So you can say that the blood flukes don't kill their hosts until the very end, so they actually, both zebrafish, the ones that are infected and the ones that aren't infected by these parasites, have an equal amount of chance of success at reproduction. You can start anywhere in the cycle as a scientist. You can make observation first, or you could be working on an experiment and have a question come up at the very end. A really important thing in science is being able to distinguish between a hypothesis and a theory. Because in our everyday language, we actually use theory as, well, a regular everyday term, like, oh, that's a conspiracy theory. So here's a scientific definition of a hypothesis and a theory, so you can get them correct. A hypothesis is an educated guess based on observation. This can be tested by experimentation. Okay, so like the last time we said, how can I tell what kind of energy is coming from the sun? That can be tested by experimentation. You can hypothesize most of the energy coming from the sun is UV rays. A theory is a coherent group of thoroughly tested hypotheses commonly regarded as correct. This can be used as explanation for a certain phenomenon. Okay, so the theory of, again, it's been tested so often, it is actually a law. It's the law of gravity. So every time I drop something and it falls to the ground, I know that there is an explanation for that that's been tested over and over and over again. And every time that experiment has been tried and tested, it comes out the same way, no matter what. So that's the difference between a hypothesis and a theory. All right, we're going to get into a specific example of the scientific method. So in 1856, a doctor named Semmelweis decided that he was going to try to do something to help his patients. He worked at a hospital, and he was noticing that in the maternity ward where women were giving birth, a lot of them, a high percentage of them, were dying of what they called childbed fever. So he was observing that childbirth deaths were 5 times higher from doctors than nurses, and he said that this is due to childbed fever. So again, here's this ordinary question. Why do people get more sick, these women, why do they get more sick when they're attended by doctors than by nurses? He also observed that doctors often did autopsies before attending a birth. And in these days, we didn't have things like rubber gloves, or we didn't even know that there were such things as germs. Okay, so he made these observations. The next thing he did was he made a hypothesis. He said that doctors transmit what he called cadaveric matter from the corpses to their patients. And then his prediction, after all he made these observations, was that if doctors washed their hands, it would eliminate cadaveric matter and reduce fever deaths. So this is something that he could actually test. He could have doctors wash their hands or not wash their hands, and then see if the patients got sick with this childbed fever. In terms of setting up your experiment, there's a couple of things you need to know. First of all, you need to know what a control is. A control is a group where nothing changes. So in this experiment, Semmelweis had some doctors not wash their hands. Okay, so nothing changed. The doctors were still doing autopsies and still coming and attending these births. Then he had 2 kinds of variables, an independent variable and a dependent variable. The independent variable is something that, as an experimenter and scientist, you change. So if I'm growing plants, I can change the amount of water I give them. I can change the amount of sunlight they're exposed to. Okay, in this experiment, he decided that he was going to change whether the doctors wash their hands or not. So he had the doctors wash their hands of cadaveric matter. And the dependent variable is what you measure for results. So what is changing in response to the hand washing? Well, it's the number of patients who are getting or not getting childbed fever. An important thing to note is that if you're noticing something like doctors not washing their hands and people getting sick, you have to make sure that whatever, they seem linked, these things, but they might not cause each other. A might not cause B, right? Like you wear your lucky pair of socks to a test and you get an A, and every time you wear them after that you get an A, right? You might start to think there's something special about your socks and you might wear them anytime you have a test. But just because something seems to connect doesn't necessarily mean that it does. Like for instance, here's a graph of rising temperatures and the number of pirates, okay? Just because those things can relate doesn't necessarily mean that higher temperatures causes more pirates. Another good example of this is in 1918 there was a huge flu. This is a huge flu. It killed like 1/3 of the people on this planet. And people were terrified of this coming back. So they gave everyone a vaccine. And unfortunately, some people started to die. And the drug companies were actually sued for this, and they went to court. A huge lawsuit battle ensued. Now here's the thing, people would die no matter if they got the vaccine or not, but people were so freaked out by the fact that there might be side effects of the vaccine that they started linking getting the vaccine to dying. So even though those things were correlated, were connected, that doesn't necessarily mean that they cause each other. The vaccine doesn't necessarily cause death. So this is an important one to remember. Correlation does not always equal causation. All right, so Semmelweis did his experiment. He noticed then that childbed fever deaths were absent when doctors washed their hands. So he did this experiment repeatedly, a number of times. So the conclusion he drew from this is that transmission of cadaveric matter was the thing that caused childbed fever. Therefore, his hypothesis was supported. Okay, so we did this a numerous amount of times. He noticed that as soon as the doctors washed their hands, less and less people were getting childbed fever and were dying from it. Okay, if the hypothesis is not supported, so say you're doing an experiment and your hypothesis isn't supported, it's not the end of the world. It doesn't mean that the experiment was a failure, okay, because you still learned something from it. It just means that a new hypothesis should be made and tested. So again, you can ask a question, do an experiment, find an answer, ask another question. Okay? It's not the end of the world. All right, for a little review. Okay, so the basic steps, and by steps I mean this can be a cycle, you can start anywhere. You make an observation. You come up with a hypothesis. You make a prediction as to what will happen when you perform an experiment. you perform the experiment, you collect your data, right? You collect all your data and you analyze it to see what happened, and you come up with a conclusion from that. The nice part is, when you come up with a conclusion, you can then go on and make another observation and start the process all over again. The scientific method is a process of observing natural phenomena which leads to asking questions and offering explanations that can be scientifically tested. So it's really a process. And when you're in this class, you're going to be learning how to do this process very, very well. So please remember the steps of the scientific method, and make sure you also remember what deductive and inductive reasoning are, because we will talk about them in class. See you next time.